Hello again, everyone. So this week for our choice board, in box number 5, which you know is always your required box, we're actually going to do two sets of notes. We're going to do section 2 from our book, which is water use and management, and then we're also going to do section 3, which is water pollution. So first, I'm just going to talk us through section 2. So when we talk about water resources, before we can talk about water management, we have to understand that when we pollute, right, or overuse a particular water supply, albeit a river, a stream, a creek, everyone that lives downstream from that can be affected because the pollution is just going to run downstream through our river. And so a shortage of clean, fresh water is actually a huge environmental problem in our world. They spend billions of dollars trying to figure out how to get people clean, reliable sources of fresh water, especially in places in desert climate communities where they don't have them. And so we look at here, our global water use. So we know our three main uses of water are residential use, which is us, agricultural, watering crops and fields, and industrial use. So we can see, and how it differs from North America through the rest of the world in terms of where we use the most amount of water. And so you can see in most continents, the bulk of the water is used in agricultural uses. The United States is one of the predominant ones using it in industry, Europe as well. That's the number one. And then we can look at our residential use. Okay, so when we talk about our global water use, again, most of them is in agricultural use, and we're using that to irrigate our crops. You can see in this picture a system that a well-developed farm has to irrigate their crops. Okay, so there are differences then in residential water use throughout the world, if you remember back to that picture. So on average, we use about 300 liters of water a day. You have had two activities where you had to look at how much water you were using. Some of you, I think, underestimated a little bit, but that's okay. But in India, the average person only uses about 41 liters of water every day. So we have to think about, what exactly are we using so much of our water on? We do look at things like watering our lawns and, stuff like that, but really it's in our house. Drinking water, the water used for cooking. Also, if you leave the water running when you brush your teeth, how long do you take a shower for? Okay, so here is our breakdown of how much water we use. So you can see something like brushing teeth is not really that much. It's only 10 liters of water, but that's something that can easily be eliminated. Okay. And when we talk about water treatment, we have to make sure our water is potable. Potable water just means it's suitable for drinking, right? Water treatment facilities, their job is to remove things that are going to be poisonous and toxic to us, even in low concentrations, mercury, arsenic, and lead. Um, these things are often found in groundwater due to contaminants, fertilizers. Water treatment facilities also in some areas are responsible for including additives. So we in this area do not have this additive, but in a lot of places they add fluoride to the drinking water. Okay. So again, water treatment facilities are designed to remove pathogens, virus, microorganisms, something that might cause disease. Also, anything from sewage, right? Sewage or animal feces. And this uses both a physical and chemical treatment. Okay, so here is a diagram of a water treatment facility, and this is also a really good video that walks you through the water treatment process. Now, in terms of our industrial water use, about 19% of our water used around the world is in industrial water uses. Water is used to manufacture goods, dispose of waste, generate power. Industries, we also, in the past have had a huge problem with water contamination, and we're going to look at that in our next set of slides. So most of the water used in industry is actually used to cool the power plants, right? So power plants, pump water from the surface. They have a cooling tower, and the biggest disasters we see in terms of cooling systems are when, nuclear reactors, we have nuclear fallout because what happens is the cooling towers, something breaks and the water that kind of surrounds the facility to keep, the reaction in check and keep things cool fails. Okay. In terms of agricultural water use, here's our 67% of water used around the world is in terms of agriculture. Okay? We talk about irrigation, right? We're providing plants with water from sources other than rain. So, lawns that have a sprinkler system, or even if someone goes outside to water the plants every day. And then we go to farms that have major sources of irrigation systems. Okay, so we also look at water management projects. So we were looking at water resources and also on the flip side, water management. So one such water management project would be a dam, right? So dams are designed to hold in water because the natural distribution of the surface water in a particular area might be inadequate or there might be so too much. And so we can see other goals, bringing in water to make a dry area habitable, creating a reservoir for drinking water, or generating electric power. Okay. We also have something called a water diversion project. So if we want to supply a dry region with water, we can divert a river into a canal to carry water across great distances. So we see the Colorado River begins as a glacial stream in the Rocky Mountains and grows larger as other streams feed into it. So it does meet the needs of 7 states. It's a huge river. And a lot of it is diverted for irrigation and drinking water before it reaches the Gulf of California. So you can see an example of this in that picture. Right. So in terms of dams and reservoirs, a dam is a structure that is built, right? It doesn't exist naturally, across a river to control a river's flow. A reservoir would be an artificial body of water that forms behind the dam. So you can see the dam in this picture and that giant body of water that forms behind the dam. Now, that reservoir of water can be used for flood control, drinking water, irrigation, recreation, and industry. And that dam would be a hydroelectric dam, right? So it uses the power of the flowing water to turn a turbine, which then generates electricity. Hence the name hydro for water and electric for the electricity. So about 20% of our world's electricity is generated through hydroelectric dams. Okay. Now, flip side, interrupting river's flow can have consequences, right? So the land behind the dam is technically flooded, people are displaced, entire ecosystems can be destroyed. You can also have sediments build up behind a dam, and it makes the land less productive in terms of growth. And then if you actually have dam failure, the people living below the river can be killed when that dam bursts and that water comes rushing towards them. Okay. And so as we talk about water conservation, we have to make sure we understand that as we, deplete our fresh water sources, water itself will become more expensive. So houses pay water bills. We pay to have water delivered to our home I think it's 4 times a year. We also, many people pay for bottled water and things like that. And these are going to become more expensive because if water comes from a well, it has to be dug deeper. We might have to, create pipe systems to pipe water from greater distances. And so it becomes a more expensive process. Okay. If we could maybe gather the water lost in agriculture, right? So a lot of the water lost in agriculture comes from evaporation, seepage, and runoff, right? So if we could reduce these, that would go a long way towards conserving water. And one such thing would be a drip irrigation system. So these will deliver a small amount of water directly to the root so that we don't lose all of that surface water when we're trying to water the plants. Okay. In industry, we can look at recycling of cooling water and wastewater. So there is no reason why the cooling water that's in that tank can't be recycled throughout when all it is doing is being on the outside of the tank, to cool whatever's going on in that system. Okay. And then water conservation at home. So using something like a low flow toilet, or turning off our water while we're brushing our teeth, or taking shorter showers, things like that. Sometimes people water their plants at night. That's one, so that we have less evaporation because the sun's not out to naturally evaporate the water. Okay, and so here's some tips for water conservation at home. Solutions for the future, we can look at desalination and transporting fresh water. So desalination is removing salt from the ocean water. So, could this be a viable means of obtaining fresh water? I guess. But remember that then if you're taking that salt water and desalinating it, it takes a lot of energy to do that. It's very, very expensive, but also then you're using your ocean water. Okay. In terms of transporting it, um, transporting anything comes with its long list of side effects. Okay. About 76% of our Earth's freshwater is frozen in the ice caps. We have actually talked about that before. So, people throw around the idea of towing icebergs to communities that lack fresh water. And so we can allow the, iceberg to to melt and we can have the water that way, but that's really not efficient right now. Okay, and so that's it for our water resources and management portion. And now we're going to flip to our water pollution.